This talk is about the quality of lake ice, and it is collaborative work, so I would like to acknowledge all my co-authors here, written on the left-hand side. And it's work which we conducted within the Global Lake Ecological Observatory Network. Why did we do this study? Well, we have come really far in the understanding of ice cover dynamics in lakes. We know when ice is coming and when our lakes are covered by ice, and we also know when ice is disappearing, and we have developed quite a few models, also global models. So on the next picture, we can see what happens in a warmer world. We all know when it's getting warmer, then the ice is disappearing, and this can also be quantified. There are different colors on the map, and the orange color shows the regions where we right now have intermittent winter ice cover, which means that some years there's ice on lakes, and during some other years there's no ice on lakes. The purple color is the scenario when we will get 2 degrees warmer winter temperatures, and this means that we will have about 35,000 lakes in the world which will lose their ice cover. And since there are many people living around lakes and they use the lakes for recreation and for fishing and other purposes, it will affect almost 400 million people when you count how many people are living around the lakes. So this has already been published and is known. But what about the quality of the ice? We have not really much information about the quality of ice. And quality can be different measures, but mostly and quite easily it can be divided into a white ice layer and a black ice layer. So the main question is now, what kind of ice do we actually get in future when it's getting warmer? Because white ice is really relevant from the perspective that it's unstable ice, so it's quite dangerous to walk on white ice. It's also very relevant for lake ecology because the transmittance of light through white ice is really much less than the transmittance of light through black ice. So we actually don't know anything right now. So that was the reason why we made a sampling campaign. And this sampling campaign was called Ice Blitz, where we took ice cores and we had a common ice protocol. People went out, took ice cores and measured at different locations and during different times during one winter season what kind of ice we have on the lakes. And this was done at various locations. All the red dots are sampling locations during the winter 2020-21. And these are more than 30 lakes distributed across the Northern Hemisphere. And we were actually quite lucky because the sampling year was one of the warmest winters since 1880. We have the air temperature anomalies since 1880 in the graph shown here, and the red dot shows the winter, which means the mean temperature in December, January, February of our sampling year. And it demonstrates quite nicely that this was one of the warmest winters, which is quite good because then we know the scenario which we can expect also in future. So how does it look like now? If we go out during a very warm year, what do we find? We find the scenario that we have ice cores where we have a typical black ice layer here, and also on top a typical white ice layer. But this is not constant over the season. We actually start in December when the ice is coming on the lakes, that there's hardly any white ice. And this is simply due to the fact that white ice is built up when we have snow on ice, which melts and can freeze again. It can also build up if we have just melting of black ice, which then freezes again. This will also be a white ice layer. So what we found is that actually the white ice layer builds up over the ice cover season. hardly anything in December, then 20% on average in January is the ice core is white ice. Then we go up to 40% in February. And then before ice off, we have the highest proportion of white ice. It's actually the dominant proportion. And the thickness is also at maximum during just before the time of ice off. And we can see this more nicely when we look at the figure from Finland, where we have measured during almost weekly during the winter season. We see that the black ice layer is quite stable over the complete ice cover season, while the total ice thickness and the white ice thickness increases over the season, and the orange area indicates the time before ice off. And the thing is that when we have warmer years, this is relevant, the time before ice off, because what happens is when we have warm winters, our air temperature amplitude is quite broad. And we have this orange area here, which means that we have about 15 days when air temperatures vary around 0 degrees, which means this is the time when the white ice can build up. So the maximum occurs when we have most variations of air temperatures varying around 0 degrees. When we have cold years, the period when temperatures vary around 0 degrees is much shorter. So the potential to build up white ice is not that the period is much shorter, so we don't have the same potential here. That means that during warmer years, the period when we can get white ice conditions at maximum, they increase during warmer years. This is relevant, and this is, of course, also quite relevant for the development of phytoplankton, for example, which is highly dependent on the ice cover, but also the ice quality. Here on the x-axis, you see the thickness of snow plus white ice. And on the y-axis, it's the light transmittance below, it's measured below the ice. And when we only have 10 centimeters of snow plus white ice, there's hardly any light going into the water column any longer, which is quite tricky for the phytoplankton to survive. So this is highly relevant. If we now switch from black ice conditions to white ice conditions, we can expect quite huge impacts on the lake ecology. But this is not all. Actually, the safety is also a very important aspect. We have, for example, countries where during warmer winters people drowned much more during conditions when we have white ice. And this is simply due to the fact that if you calculate the allowable load on ice, there are formulas taking the density and the quality into consideration. And you learn at school that you need to have 10 centimeters of ice so that you can safely walk on the ice. Yeah, if you have pure white ice conditions, that means it only holds a bit more than 100 kilograms. And you also learn that you should not go out alone on the ice. You should be at least 2 people. Yeah, that means if 2 people walk here on the ice, the allowable load is actually, it doesn't hold 2 adults because they usually weigh more than 100 kilograms. But if you instead have pure black ice conditions, if you have 10 centimeters of black ice instead of white ice, then the allowable load is more than 1,000 kilograms. So there's a huge difference in the stability of ice. And this needs to be taken into consideration. So our ice safety guidelines, which we have right now, they need to be adjusted to the warmer winter conditions. And we made some suggestions how this can be done. And as a rule of thumb, you could say, actually, you need the double of total ice thickness, 20 centimeters, to be more or less safe to walk on the ice. So the conclusion is, yes, we go towards critical white ice conditions. Critical for the lake ecology because the light transmittance through white ice is not as much as the light transmittance through black ice, and it's quite unstable if we have white ice conditions. So we need to be prepared for that. Thank you very much for this